Thank you very much for coming to this session about, from prompts to workflows, or, how to build agentic AI with Java. I would say that in this session, it's like two parts. One, which is like an introduction of, let's say, all the features that we can use when we want to develop an AI application. And the second part, which is more how to use it for developing agents, which is, kind of a different thing. At the end, it's the same. It's just a matter of putting a name. But well, yeah, we'll see the differences. Okay. So my name is Alex Soto. My Twitter is Alex Soto B, and my email is sotoboy@ibm.com. And yes, you can send me an email, no problem. For this reason, the mail is here. So feel free to send it. And then there is this QR code. Basically, I'm the co-author of all these books, and some of them can be downloaded for free. You're gonna scan the QR code, you go to developers.redscat.com, you register, it's free, and then you can download it, the PDF. I think that for now, you can only download it two, which one is about Ansible. So if you want to get certified of Ansible, yeah, I'm sure that here there is not a lot of operations people, but in case, you can do it. And the second thing is the Applied AI for Enterprise Java Development, which covers some of the parts of this talk. So I know that in the AI space, most of the people are using Python, right? Yeah, that's true. But well, if you love the planet, yeah, maybe you should start considering using Java instead of Python. You see here how you are saving energy when you are using Java. Yeah, of course, if you want to keep your mind, piece out of the Python ecosystem. I don't know if you have been working with Python a lot, but it's super funny when you have something in Python that works with 3.23, doesn't work with 3.22, but it works with 3.21. And it's like, what? I mean, that it's just a minor version, or what happened with 22? Okay, that's good. And also at the very end, big corporates uses Java, right? Because we need observability, we need ORMs, we need resiliency. We need also to know how to put this into production and live for a long time, right? So I think that Java and the JVM works really well with this. So if you have 0 Python application in production, that remains the right number, okay? That's all. I mean, that I thought that I hate JavaScript, but no, I hate more Python. Not the language, but the ecosystem, right? The language is great, but the ecosystem, yeah, okay, that's good. Then let's start with the first tag, right? Which is like, what is LangChain4j, or what we can do with LangChain4j. Basically, maybe when we want to interact with a model, we'll say, hey, yeah, at the end, the models are, are inferenced with a REST API. So we could just access this REST API. We could just create a REST client and so on. Yeah, you can do it, but as this B, you know that this B is missing something. And this is what you're going to miss if you implement on your own the REST API to access a model, right? For example, complex prompting, or what happens if the mappings of this REST API changes. So for the reason, what we've got is LangChain4j, which basically I like to say that it's like Hibernate, but for models, okay? Basically, it lets you, first of all, create complex promptings, system messages, user messages, templates, okay? It lets you also create templates, so it's good. Also manages all the memory stuff. We know that models are stateless, so we need to provide some context, some memory of our conversations, right? So this is automatically managed by LangChain4j. It also lets you implement RAG systems. And when I mean RAG systems, I'm not saying, oh, yes, I am just ingesting these documents, and then I just, put it there in a vector store. I'm just talking about complex chunking strategies or complex RAG operations like multi-layer vectorizing, okay? So it works really well with this. Also implements a function calling array, or also MCPs. We'll see in a moment. Probably you know that models has no dynamism, right? We cannot ask them, what is the weather today in Barcelona? We cannot do that. So how we can make models do, or could ask, or give us a response for this question. Also, LangChain4j acts, as I said, as an Hibernate. So you can have different models, right? And then maybe you're using OpenAI, and then at some point you change to Amazon Bedrock. You only need to change one dependency and done, right? So it's this kind of magic. And also it lets you implement agents, which we're going to see by the end of the session. So how are we going to start using LangChain4j? Well, in this case, I'm just showing you how to use LangChain4j in Quarkus, but it doesn't matter because LangChain4j is or it works with vanilla Java. So you can do a void main method and just start using LangChain4j. You can just use it LangChain4j with a Spring Boot. It also has the integration with the Spring Boot. In this case, I'm going to show you with Quarkus, okay? Then, how it works? Well, basically, you add this dependency, the LangChain4j OpenAI. If you want to use Bedrock, you add the Quarkus LangChain4j Bedrock, okay? And this basically switches the model. In the case of using LangChain4j alone, just changes the coordinates, that's all. Then, you need to configure the application. Basically, you say, in this case, the API key for OpenAI, and you can just, for example, say, hey, log me all the requests, log me all the responses, well, the temperature, and so on. Then, we only need to create an interface, and that's kind of, what I love about LangChain4j, because I do not need to write any class, just an interface that I said, hey, you see here, I'm saying register as AI service. I'm saying this is an AI service, okay? Then I want to add some kind of system message, so like initial instructions and context for the model. And then you see here that I'm setting here the user message. And you see that this user message is a prompt, and well, it's kind of more complex because it's not just text. It has some, you see here some placeholders, and then automatically LangChain4j makes the matches between the arguments and the prompt. So automatically it replaces at runtime the you are professional poet, okay, nothing, then write a poem about, and then it will replace the topic with the given topic and the lines with the given lines, and send this to the model. Just these lines. And we are interacting with a model. Of course, we can use the low-level API, because what I showed you before is the high-level API. It's like, okay, create an interface, no access to the low-level stuff. Then, how you can do that? Basically with inject chat model. So I'm just injecting the low-level object. This basically lets you, for example, define the user message not with an annotation, but with a class. You say, hey, this is a user message from text and from an image. So you can, you can mix the contents, and then say model.chat. You set the user message, and done. And then you can do response.ai message, you get the AI message, you get the response, and so on and so forth. For example, you can get things like if a tool was called or not, and things like that, okay? So this is the low level. That's great, right? Because it's easy to either use the high level or the low level API. Now, why this looks good? Basically because everything is typed. You see that it's Java code. There is no, no strings, nothing. It's testable. The prompt is separated. You can just have, annotated or within a string coming from a file, and it basically injects very well into your code. Basically, using, in the case of a Spring Boot, with AutoWired, in the case of let's say, Jakarta EE, with CDI. So, yeah, it works really well. The problem is that you might say, hey, yes, that works really good if you have a string and it returns on a string, right? So for a chatbot, I'm sending a text, a free text, and it returns me a free text. Great. But what happens if I want to make the response make machine readable? So basically say, hey, I don't know, here is the text. The invoice probably contains an IBAN number and a name and a date of the transaction and so on, right? Things like that. And I want to parse this text and get back. Okay, if I got a string, this is not human readable. It's not machine readable, sorry, it's human readable. So what you can do is things like that. You can, instead of return a string, you can return a Java object. In this case, an invoice data. So you create invoice extractor. Notice that here, I'm just showing you how to do it with LangChain4j vanilla. So with no Spring Boot, no Quarkus, nothing. So you'll see that the idea is the same, but only changes the annotations. So you create the interface, a system message, extract, a structured invoice data, and in this case, I'm just not putting any user message, so automatically LangChain4j uses the argument as a user message. And then it returns a class. Then, what's going to do LangChain4j? Easy. This is the class. I'm going to use JSON marshalling stuff for transforming the text that is coming from model, which basically it's a JSON file, to an object. So it manages all these kind of things automatically. So then, of course, you need to do the chat model. Remember that with Quarkus, we just injected the chat model and it worked. Magically, Quarkus takes all the things and configures the objects. In case of vanilla, of course, there is no container, CDI container, so you need to do it manually. You do chat model, OpenAI, chat model.builder, you put the OpenAPI key, the model built, you get it the model, and then you just do AI services.create, and just set the interface, you put the model, and you get it this running. So in Quarkus, you've got all these, let's say, code or boilerplate code replaced by the framework. If not, you can do it in this way. It's all good. In a Spring Boot, it's exactly the same, okay? It's as in Quarkus. It just does everything automatically. So now, basically, with this approach, all the stuff that are coming from a model, it's validatable, persistable, and testable, right? Because it's in a Java object. So we send in a string, we get it a Java object, which automatically gets all these fields populated, and we can write tests. So, good thing. Problem is hallucinations. What's happened when the model is say, hey, this is the, this is the text that I want you to parse and fill all this class. And yeah, of course, model will try to do its best. Basically, doing its best by taking the name of the fields, which is not always maybe possible or not descriptive a lot. Then you can just do a JSON schema enforcement. So you can create programmatically a JSON schema, right? In this case, you say, hey, just there is a root element which is a JSON schema with name, age, it's required name and age, and so on. So you define all the schema. And then in the user message, you've got the user message, and you create a chat request parameters where you set, as you can see here, the schema. So this instance goes inside the params, and then you do, okay, chat, user message, chat request parameters. In this way, what you are saying is sending the request to the model, but you're also saying to the model, hey model, the response is a JSON, because it returns a complex object, but this object needs to follow this schema. So let's say that you help a lot the model to not start hallucinating, and you get more predictable results. Okay, this is how it works, all this, let's say, standard prompting with LangChain4j. Now, as I said before, a model has no way to interact with the external world per se. I mean, if you ask to the model, what is the weather in Barcelona? The model will say, hey, I have no idea. Or it will hallucinate and tell you something like, oh yes, usually it's sunny. Yeah, probably can do things like that. Or yeah. But what the model providers, let's call it in this way, did was creating these tool callings. Basically, is a way that have the models to do remote calls. And as I said, it's a remote call. It's like the old RPC that we've been doing for a long time, like, well, the old ones, Corva and RMI. If you are not that old, maybe AGVs, and now then REST, SOAP, and so on. It's this. There is nothing new on that function calling. What is important to understand is that the LLM is the client and your application is the server, which means that the LLM only decides to invoke or not the function. But it's your application who's going to run the function. It's a remote call. Then, how it works? Well, it works in this way. Basically, we've got a lot of tools. In this case, we've got one which is like get weather. And when you send the request to the model, you send the system message, you send the user message, and also all the signature and descriptions of all the tools or all the methods that are available. So you send all this to the model. Then the model will start, getting his things and say, oh, the person is asking me about, I don't know, the weather, and I don't know nothing about weathers, but I know that there is a method that has a description that say, hey, if you need to know the weather, invoke me. And also I know that, it has some arguments of that type and so on. So what I'm going to do is, hey, application, can you invoke me the getWeather method? Then the application will just run the getWeather method, get the result, and send back the result to the LLM. Just keep in mind that this consumes a lot of tokens, right? First, because at the first request, you're sending a lot of extra information. So the more tools you've got, the more information you're sending to the model. And the second thing is that now when you're sending the result, you're not only sending the result, you're sending, hey, for the original request, I invoked this method, and this method has these parameters, and so on and so forth. So you're just kind of duplicating, right, from invoking from method to method, the amount of tokens that you need. And yeah, that's how it works. Then how you can define this is super easy. You go to your AI service and say, this AI service can use a tool, which is the weather tool. This is just a class, you'll see now. Or if you only want to invoke it in a method, so suppose that you've got several methods in this AI interface, you can just use the annotation toolbox, you pass the class, and that's all. And this class is something like this. It's a class that has a method or multiple methods with, or annotated with tool. You put here the description, search for the weather of the given city. You, in this case, you know, I'm defining also an argument. That's all. So with just this line of code, you are adding to the context of the chat interface or the chat method, this method as well. So every time that I run or invoke the chat method, the original chat method, this one, I'm just also sending the signature and the description of these annotated methods. So you'll say, okay, great. Now I can just start, annotating all my code with tools. If I need that the model can invoke that method, but there are some problems. First of all, is that your application and the functions must be in the same language. You're seeing here that, okay, my AI service is in Java and my tool is also in Java. Of course, because you need to put everything here together. Then, yeah, it's great, works, but there is no interoperability. You see that, okay, what's happening if my application is in Java and I've got a tool that is implemented in another language? Let's say Go, because I don't want to say the other semi-languages or, yeah, let's call it wherever. This is the first thing. The second thing is that they are hard to reuse. What's happening if my getWeather tool must be reused by several applications? Yeah, if you are in Java, that's fine. I can create a jar file. I add the jar file into the class path, done. But what's happening if the other application is not in Java? Or, yeah, okay, it's like, okay, now I need to manage multiple versions of the same. So it's kind of difficult. What we've got then is the MCP, the Model Context Protocol Standard, which is an open standard that basically lets the AI models connect to tools in a standard way. So no more, let's say, problems of, hey, the tool is in Java, I need my application to be in Java. No, because now there is a standard, and since there is a standard, your tool could be in Go, and my application can be in Java, or I can reuse this function to all my projects. Then you see here that now there are like another piece here. One is the MCP per se, another one is the application. And it works like this. I've got my application and I've got the MCP server. Basically, the MCP server is the bridge between the MCP protocol and my real application. In this case, I put it an example with GitHub MCP server. Basically, this GitHub MCP server is a bridge between MCP protocol and GitHub REST API. Okay, so it's this kind of bridge. Now, my application maybe says, hey, when I start my application, you register all the MCP clients or all the MCP tools and say, oh, look, I've implemented an MCP client, which is, I don't know what. Give me all the tools that you are representing, right? And then ask to the GitHub MCP server, and the MCP server says, hey, look, I've got all these tools registered. For example, get repository tree, add issue comment, issue read, search issues, and so on and so forth. Okay, Now I've got all these tools. Now I am going to send a request to the user message and say, can you fix the issue number 67? And I'm going to send this to the LLM. Remember that since we've got all these tools, what I'm sending to the model is my user message plus all these methods. Now the LLM will say, okay, you asked me to fix the issue number 67 with all the list of these tools, but I need to know about what is this issue number 67 because I have no idea. So what I'm going to say is, hey, application, remember that now it's an RPC application, so my model is doing nothing. The model is just saying to my application, invoke something, which basically is invoke the issue read with argument number 67. So my application will use the MCP client to connect to the GitHub MCP server saying, hey, can you read the issue number 67? Okay, then the MCP server will connect to GitHub. The GitHub will return the description to the GitHub MCP server, and the MCP server will get back me the results saying, okay, there's a null pointer exception at this, blah, blah, blah. Okay, all the information. Great. Now I've got everything. I put it together, everything, and I send to the LLM. So you see that in this case, it's the same as a function of calling. But the big difference is that I've got this MCP bridge in the middle. Means that I can just start a GitHub MCP server once, and this instance can be reused by all my applications in the same way. And the GitHub MCP server can be in Go, and my application can be in Java. Now, how do you develop an MCP server? Of course, you know that, and there is a lot of MCP servers out there like this GitHub, the Terraform MCP server. I mean, there's a lot of them, Kubernetes MCP server, right? There's a lot of them there, but you can also implement your own MCP server. Basically, in this case, I'm just creating an MCP server using the SSA. So I just add the transport protocol. If it's STDO, if I want to use this transport protocol, then I just need to change the suffix from SSA to STDIN. Now, I only need to do this. Just a class with a CDI bin. This is, of course, using Jakarta E, in fact, okay? Then you define a tool, the same annotation that we've seen before, saying, hey, I want that you expose this method as an MCP server method. Then I can even describe the arguments. If I do not describe it, that's fine. The LLM will try its best, but you can always, use the tool arg to describe. And that's all the things that you need to do, nothing else. So you can just create an MCP server in Java with just 3 lines. Just this, one dependency, one class, one method, done. Of course, depending on the logic, it will be more classes or not, but that's the scaffold thing. Now, just a remark for Quarkus. By default, Quarkus doesn't do Uber jars. Okay, so when you are starting using an MCP service especially with STDIN, you want to run them easily with Java -jar. You put it the jar and done, right? This is what you want. So in the application properties, I recommend you put it this Uber jar, and then Quarkus will create a Uber jar instead of this special Quarkus packaging. On the client side, it's not that hard. Add the dependency. Again, this is the Quarkus dependency, but if you want to use vanilla LangChain4j, there is the io.langchain4j, and it's LangChain4j MCP, and that's all. And now you use this other annotation. Say, hey, this is the AI service. Now, instead of using the toolbox annotation, remember, now I'm using the MCP toolbox with a name. The name is, in this case, Zodiac. Now, where do you define this? Here. In the application properties, you say, hey, there is the Quarkus langchain4j.mcp.zodiac. The transport is HTTP, and the location is this host. Done. With just this, now every time that I invoke the askMe method, I will go to, I will send all the MCP server methods to the model, and if the model requires, it will just go there, take the method, ask to my application to invoke it. And then, of course, LangChain4j will connect to my MCP server, make the request, get the response, and so on. So it's, I know that there is a round trip around, but you are getting a great abstraction. Third act is about skills, because, okay, now I've got my prompts. I know how make my model invoke my methods, but, well, you know, this is a guitar. Yeah, and it's a tool. And the LLM is a tool. But here is the key point. This tool is not used in the same way by Brian May or Billy Armstrong, right? They have different music styles, different ways of playing the guitar. They have different skills. And that's exactly what you can do with skills. Basically, what you do with the skills is saying the model how it should behave. And basically, a skill is a folder with instructions, most of them in Markdown. The mandatory file is one named skill.md, where you just create a Markdown file with kind of instructions. And then you can also add extra folders, like, for example, where you put assets, scripts, wherever you put their code, wherever there. Then, in the skill.md file, you put the metadata of your skill and all the content. For example, invoke this script, and the script is, it knows that it's in this folder, right? And this helps a lot of reusability, because you've got a skill.md file or a folder that you can reuse to different projects. For example, using, I don't know if you, skills jar project, which is a project that lets you reuse skills using, package it as a jar file. So it means that your skills are a Maven dependency. So you could just put it as a Maven dependency, and then the skill is available. You can share it, of course, and they're writing natural language because it's Markdown. And one thing that you need to be aware is that you append the skill as a context, which means that your prompt gets bigger, so more tokens. But there are a lot of studies that says that skills uses less tokens than MCP tools. So always tries to use skills if you can. If not, then go to tools. And it works like this. Okay, this is the, the folder, my skill number 1. I can have a lot of skills. Then my skill.md has the metadata. For example, here there is a name and the description. And then there is the, a description of things. For example, to process an order, call this method, call this other method. Only if reservation succeeds, call this method. Finally, call this other method. If any step fails, call BAM before reporting the error. So you see that I'm just kind of defining how I want that the model behave under, for example, processing an order. Now, how this works? Okay, I can have a lot of skills. Basically, when I just do a request to the model, I'm just adding the system message, the user message, and the metadata. So this part, okay? The name and the description. Then I send all this to the model, and then the model will just analyze all my user message, all my description of the skills, and then at some point will say, hey, I'm interested in this skill. So can you activate this skill? Then my application will go there, find the skill, append to the context all the Markdown file with everything, and then finally send it to the model. So now the model will have your user message plus all the instructions of the skill. What is important here is that this is the metadata, and the name should be in a folder with the same name, right? So if the name is poem writing, then inside skills, which is the default folder, needs to be into a poem writing. If not, it's not going to work. As I said, by default, you put all the skills into a skill folder, but this is configurable. And you only need to do this. We provide this system message provided supplier. You add the skill system message provider. You just annotate your AI service with this. In the case of the vanilla LangChain4j, it's similar, not using the register AI service, but using another annotation or method, and that's all. And all the magic happens. As I said, by default, the skills directory is in skills, but if you want to customize, you can just use this property to customize it. Again, easy, just one line, you provide all these skills things, and it's done. Yeah, of course, you also need to add this dependency. In the case of, again, in the case of LangChain4j is io.langchain4j, LangChain4j skills. In the case of Quarkus, then it's Quarkus LangChain4j skills. In the case of Spring Boot, I don't know exactly, but it's going to be Spring Boot LangChain4j skills. Then, another thing that we need when we are implementing AI applications is that our models are stateless. They have no memory. And when we want to do a chatbot, we need kind of memory. Because if I ask to the model, hey, can you check the weather in Barcelona? And say, okay, the weather is this one. And then you can say, okay, and what flights are available to go there? This there, it means to Barcelona. But the model has no memory, so has no clue of what is there. So basically, what we want to do with models, especially if we do a chatbot, is that they need to have memory. And how we can do that? Okay, with LangChain4j is super easy. Basically, it's I send a request and I get it a response. That's good. Then I send another request. But the important thing here is that I'm sending the new request appending the previous request and response. And then I will get another response, which is the green one. Then I'm just sending another request. So in this request, I will have the original request, the response of I got it, you know, in the first interaction, the response of the second interaction, and so on. That's how it works. Appending context all the time to the message. How to do that? Well, with Quarkus, you do not need to do anything at all. Just all the requests are always stored, so you always have memory. But, and that's the key point, it's only enabled per request. It means that if I send a request, when I get the response, the memory is lost. So you get memory if you have several interactions in the same method, in the same request, then it works. If not, the memory is wiped out. Okay, that's how it works. And stores all these messages into a default in-memory store. You can also set the max amount of messages that you want to store. And then, of course, you can just not use a memory store, but another store, for example, using Redis, right? So if I add this dependency, now my messages will be stored in Redis instead of the in-memory. This works really well if you want to stay, right, or you survive to any kind of breaks. Then, of course, the problem is that, hey, I need memory that lives across requests. Then what you can do is annotate your AI service with application scope. And you see here that I'm using this memory ID annotation. Basically, if this is application scope, it means that all the requests uses the same instance. So I need to verify that this is my memory and not the memory of another request. So you are using a memory ID, which you can just set here a string ID, which could be your user ID. Basically, internally, it's like a map, right? So if you need to have multiple users using the memory, you need to have a map to define which are the memory of each of the users. Then, one of the great things is that if you're using Quarkus WebSocket Next, you only need to set this as session scope. And you do not need to do memory ID, because automatically Quarkus uses the WebSocket session ID as a memory, right? So you do not need to do anything at all. So we are great, right? Now we've built all this B, we've got the memory, we've got the prompts, we've got the skills, we've got the MCP tools. So we've got everything. Now, when we are using all this everything, or most of the parts of this B, we've got an agent. So if you're just doing prompting, okay, you're doing prompting. You do not have an agent, but you're using prompting, which is great. But when you have using most of these things, now we can consider that you are using an agent. And this is when we start with agents. So agents. Basically, what happened here is that, okay, I've got my application, which is a monolith. I'm using some prompting and so on. At the end, I start using memory, MCP tools, and so on. So now I've got one agent. The problem is that usually my application will end up having different agents. For example, if I'm a travel agency, I will have an agent for booking flights or finding flights, another for car rentals, another for hotel bookings, and so on. So probably you will end up having different agents, not just one agent. And remember that one agent is prompts plus memory plus, calling tools and so on. And you will need some kind of, first of all, coordination, right? In the case of travel agency, I will need to book or find flights, find hotels, and so on. Also, all these agents will share common data. If I'm, again, with the travel agency example, if I want a flight to Amsterdam from one date to another date, I need the dates and the place, right, in all these agents, because I need to find a book, or I need to book a hotel in Amsterdam, and I need to find a flight from Barcelona to Amsterdam. So I need this information. Now, how we can do this thing? Okay, we can do it with patterns, with agentic patterns. Basically, agentic patterns are a group of, as the same, of schemas, right, that let us make calls between agents. For example, sequence, parallel, loop, conditionals, routers, and so on. So this is an example where you can have the sequence and parallel patterns working, right? I've got one agent, which is the flight. First, I need to find the flight, because depending on when is the flight, I need to book the hotel, right? So first, I find the flight, then I find the hotel. Then in parallel, I'm going to find some activities that I can do in my destination, and all these agents shares the agent scope. Basically, it's all this information. And this is what I called like a microlith approach. Basically, is your application has different agents defined inside this application, so there is no remote calls between agents, so it's all together, but the good thing is that they are modularized. Okay, so you've got your agent modularized in the same application. How this works? Well, it's super easy. Add the dependency, again, LangChain4j Agentic or Quarkus LangChain4j Agentic. Now, instead of using register AI service or anything, you use the agent annotation. You can also use the AI services annotation that we've seen before, user message, MCP toolbox, and so on. And then in the agent, you set the output key, because at the end, you're running several agents at some point. Maybe if you are running them in parallel, so you need to know the output of each of the agent. So you said here, okay, this is movies, and then there is a method that says find movie, this is the mood, I use the user message and so on. So this is an agent that I'm going to use for finding a movie. Now, this is just an interface that I can inject again, as I did with the AI service. Movie expert agent, I can call the find movie, and it will work. Now, the important thing here is that now I can just start creating, let's say, workflows. For example, in this case, I'm just creating a parallel agent, as you can see here at the beginning, parallel agent, which the output is plans, and I've had two sub-agents, the food expert and the movie expert that we've seen before. Now here, this is the method plan. This is where I want to execute this in parallel, and this is how I can compose the output of both of the agents, okay? So you see that now I'm just creating like a super agent, if you will, that are going to use in parallel two other agents. This is parallel. You can also do it in sequence. So you use sequence, and then here it's going to first use the creative writer and then the audience editor. I can just do a loop agent. So I can say, hey, just start looping through style scorer and style editor. The output should be in the story, and the exit condition is if the score, so the score is something that is coming from the agents, are greater or equal to 0.8, or if I do 5 iterations. Okay, so when I do 5 iterations or the score is okay, I will stop looping through all these agents. Also, I can do a conditional agent. So I've got two agents, medical expert, technical expert, which I need to call. Okay, then I've got the activation condition annotation, where basically say, hey, activate the medical expert agent when the category is medical. Now, basically, I will have another agent, which basically will classify the input message or the user message. And in this case is another agent that returns agent category, like here. right here. Okay, so basically I'm just saying, hey, check, find the request, send it to the activation condition. You will have one activation condition per agent, and then finally it will just, find the agent and invoke only this agent. And as you can see here, also we will have an expert router agent, which basically first categorize, right? So find which is the agent, and second calls the expert agent, which basically will choose the exact agent. So you can see that you have started composing patterns of agents. Now, of course, this was a microlith application approach. But what happens if I have several services, right? Several agents, and maybe some of these agents I want to be shared across different other agents, or maybe the agent is deployed in another part of the organization, or I don't know, Google agent, and I want to use this Google agent. How I can use this other agent if it's remote? Basically, we've got the A2A protocol, the agent-to-agent protocol. Again, it's a standard, which is enterprise ready, and it works really well. It works like MCP, but for agents. And one thing that is important with A2A is that you create agent cards. Basically, you are describing what is the purpose of the agent. And this works really well when you want to make agents do things autonomously, because then they are able to just read the agent card and understand the purpose of this agent. So basically, it works something like this. I've got, in this case, a microlith application that requires two models, the scorer and the styler, but then I've got another model, which is the writer, which is a model that understands or knows how to write books, but it's remote. So my application will do a remote call to the writer. The writer agent will return me a result using the A2A protocol, and then I will start this looping of a scorer style till the book is correct. But the key point here is that the writer is out of my application. It's in usually in any HTTP remote site, and the scorer and the styler are running, not running, I mean that are part of my application. How to do this? Super easy. Again, this is the creative writer. Remember, the creative writer is the remote one. So how I connect to this remote agent? Okay, I just create a creative writer. In this case, notice that I'm showing you the programmatic declaration approach. So I'm not using the annotations. And then I just said, okay, agentic services dot A2A builder. I set the URL, done. LangChain4j does the rest for you. You just say, hey, you see that the definition is exactly, that is a creative writer. It's just an interface. Here is exactly the same, but the only change I'm doing is that when I'm creating the creative writer, in the first point, there is no agent. So in the first point, I'm just defining the agent as local. In the second part, I'm defining the agent as remote. The only change is that I'm using the A2A builder method. So another pattern that I love about agents is the supervisor agent. Basically I've got an agent that knows, or they have a list of agents, right? And then the supervisor says, hey, planner, the user asked me this question. And you've got all these agents, and see that these agents can be remote or not. I know that these agents does this, and that. Just plan what is the best execution flow to resolve the question that the user has. So you see that now everything is autonomous. There is no workflow. These are the agents. This is the question. Find the solution. It will just start doing planning things, finding the solutions, and finally gets you the response. And to do the supervisor agent, you only need to do this supervisor annotation. Again, interface, supervisor agent. I put the list of agents. Here in this case, I put here a method, and that's all. And now let me show you an example that shows all these things. Here is the link. You can run it for your own. I have not started yet this project. Just you see that it's super easy. The first thing is a front end. I'm going to do npm run deb. So I'm just starting the front end in JavaScript. Now here I've got my backend. In the case of backend, I'm going to run it using event wrapper, Quarkus, deb. Basically, I'm starting the backend now. This backend uses PostgreSQL databases and so on, but one of the great things about, oops, I don't know. Okay, well, if you want, I can start it again. I mean, that is just starting Quarkus dev mode. Basically, I'm starting the application in Quarkus dev mode, which starts a PostgreSQL database for me in my Podman instance and so on. So now it's here, it's running. And then here, I've got an MCP server. I'm going to start it again. So now I've got, oops, I've done something wrong. No. Basically, I've got front-end, back-end, and MCP server that are running. Okay, this MCP server could be running somewhere. Now, let me start here the application, here, localhost. Okay, so basically it's Laxium Travels. Okay, here I've already logged it with Alice. I can just go here and say my bookings, and these are my bookings. I can, find flights, I can book flights and so on. But one of the important things here for this talk is this chatbot. To say, hey, I'm just here to help you, and I can ask, can you give me a list of my bookings? Now, while it works, just tell you that I'm using the supervisor pattern. So I just have a list of agents and MCP tools for accessing the database for finding my bookings, or, as you'll see, to get the local time of each of the planet, right? So I just have a lot of things there, and the supervisor pattern will do, find my question, find all the stuff that I give to him and say, yeah, I'm just going to start running this, and that, and finally, it returns my bookings, okay? If you see here, in the logs, you see that it's saying it's just logging all the invocations. So you see here that it says agent invocation. I'm invoking this agent, then I'm invoking this tool. Then you see here this the SQL query, and then finally, okay, now this is done. And since the supervisor say, hey, you asked me for bookings, and now these are bookings, we are done. Okay, this is how it works, and it's really well. Now I've got here, nope, sorry. I've got it a complex prompt here. It's like, can you, hope that it works, provide me the local time at arrival for my booking number 11. Hope that it works. Because, yeah, it's a supervisor pattern that does whatever thinks it's best. Let's see if it works. Okay, now it's doing yes. You see here that the MCP server was called. And finally, it says, the local time at arrival for your booking number 11 is this, Martian time. Okay, remember that my booking number 11, you cannot see here. Not here. Okay, well, I won't show you here. It's to Mars. The booking 11 is to Mars. So I've not done anything. You can see in the code. This is not, wait. Here. Okay, I've just created this supervisor agent with a booking agent and a time agent. Basically, an agent that knows how to transform times from Earth to any solar system planet. Another one that is for bookings. You can see here the booking agent. Okay, this is the time agent, which is this other one, and then the supervisor just magically said, oh, you're asking me for a time for booking number 11, and yeah, the time is in Earth, but the destination is in Mars. So, okay, what I need to do first is finding the details of booking number 11, and then when I find the booking number 11, I need to get the destination, and then invoke the other agent for transforming the time from Earth to Mars, right? So it's really, really impressive. Now we are almost getting out of time. So I will say that Quarkus for business logic works really well. Of course, if you're using Spring Boot, yes, LangChain4j works with the Spring Boot. In fact, with Micronaut, with all the Java technologies, it works really well because it's at the end, it's LangChain4j is framework agnostic. You can use A2A, you can use MCP, right, for remote communications. And then, of course, don't get crazy. I'm going to start using an agent, a supervisor agent. No, start with prompting, then, structured output, then tools, rack, agents, and then finally move all this knowledge to your enterprise. Of course, AI is just the cherry on top of your sundae, so you still need infrastructure. Your application still needs to be predictable, okay? And then, yeah, this is the QR code for the slides. So if you want to, get these slides, in the later, you just scan this, and then you've got also the QR for the books. And if you want to run the demo, you've got the link also there, and you can run it locally. In fact, the demo is super bigger than this, but for the AI part, it's just this thing. So thank you very much for coming. We are out of time. I mean, that if you have any question, I will say come to here. Happy to help you. And yeah, I mean, I will be around, so feel free to approach me.